We are Team 3, and we are going to present our toy today. I am Shadwell.
I'm Luke.
I'm Lauren.
John.
So, our toy. It's a car. It's a boat. It's a submarine. Our toy is the USS Zumwalt. The project prompt was to either make a video game that can be brought to life, an ancient mechanism, a transforming toy, or something that has an artistic expression, or even a mechanical bank. We were initially thinking about a mechanical bank, but ultimately we stuck to a transforming toy, and we think that it's awesome. Some of the design inspirations for the toy, we want something that can be used in a variety of situations, because kids are sometimes limited to a certain specific area, and we thought that it should be a toy that can be used either in water or in a dry place. It should not be limited. If Batman, James Bond, and others have featured cars that can go on or underwater, then why can't a toy? I'm going to hand it on to Luke, who's going to help explain some of the initial concepts.
Okay, so our proposed toy would have a target age of 8 and above. We really feel like this could have an appeal to an age range from all the way from elementary school age, even potentially into high school age. But there are RC hobbyists of all sorts of different ages, so we really feel like this toy wouldn't be limited to a specific age range. And this can be attributed to the high play value. The 3 different modes of the toy allow it to be used in almost any environment, whether that be indoors or outdoors, on land, or in almost any kind of body of water, whether that be a pond, pool, or a lake, or even a bathtub. And we know this toy would be very unique to the toy and RC car market, because while there are toys that can transition between a car and a boat, none of them take it as far as to also transition and then into a submarine. And so this was our first initial prototype that we carved out of a foam block. And the purpose of this prototype was just to kind of nail down the aesthetics we wanted to incorporate into the toy, and also to get some rough dimensions for key features on our toy, like the placement of the wheels, the placement of the piston, and so on. And so some of the technical aspects that actually make our toy work are the propeller to move the boat and submarine. We actually incorporated into the wheels of the car, and so the propellers actually function as the spokes of the wheel. And the wheels will pull water in from the sides of the boat and take it through a channel, and then actually jet out the back, which will propel the boat and submarine forward. And then to transition into submarine mode, the periscope of the submarine is actually attached to a piston. And so when you pull the periscope up, water will be drawn in from the bottom of the boat and through a series of holes, and it will take on water, moving it down to a submarine. And then to transition back into a car or a boat, you just have to push that periscope back down.
Alright, so for our drive mechanism, we originally basically, as you were saying, for the wheels, one of our original concepts, what you saw in the drawing, was the back wheels to actually detach and move to the back and act as the propellers for the boat. But then we were thinking, shoot, now we need to carve a path down to the water to actually pull the water into those propellers, which kind of made us think, why add more pieces that could break off or get lost or misplaced? Let's leave the wheels where they are and dump the water behind them to shoot it out. We decided to originally drive this with a gear mechanism. However, due to difficulties in trying to laser cut the gears, we switched to a gear and pulley system, which we will hopefully see here in a second.
some technical glitch.
No. But the wheels will spin and water gets jetted out the back, which works both in submarine and ocean.
Jeff's apparently got
There we go.
That's why he's our TA.
Okay. So then for the piston mode, we actually have it spring-loaded with a latch so that when it's in car or boat mode, it will stay down. We decided to find it. Okay. So we have a latch mechanism on top that will hold it down while it's in car or boat mode, so that the piston will actually be hidden from view. But then you pull the lever on top, and the spring will push it back up, allowing it to take on water in submarine mode to sink. We added an additional hole through the piston so that we didn't clog it with an air cavity in there, because otherwise, if you pull the piston up and it just has, if there was any air in there, if you were to be playing with it and it set down in the water, it wouldn't be able to take on the water. So we had that in that hole so that it didn't create a vacuum on the top of the water. And then you're okay with it?
So we'll see if it works. We were having some issues with actually the fully drive just this morning. Theoretically, so float, so that's a good start. It looks like, I think we're using an O-ring to drive it, and I think that just lost tension. However, so as you can see, the wheels are actually pulling the water and jetting it out the back. So we were pretty excited when this actually ended up working as we designed. But we weren't able to get the sub mode working for today, mostly because of 3D printed parts. We were trying to use both the MakerBot and the Visiotech and try to make those parts in the piston, and it just didn't seal quite like we were hoping it to. But we should be able to at least demo the up and down motion a little bit. So it actually does go up and then up and down. So the idea is that would actually push water in and out, calling it to float or sink. So some of the challenges, like Barbara mentioned, it was really difficult to tolerance with 3D printers. You're kind of supposed to increase the size so you can account for shrinkage, but then maybe it doesn't shrink quite as much as you think, and all of a sudden you come over to so that was one of our big challenges, along with the working from the Visiotech. And then also we had to add an extra acrylic sheet to try to make it waterproof because the MakerBot material itself is fairly porous. Some iterations. This is pretty much our first iteration at the design. So we improved the shape and aesthetic of the boat car. We incorporated the battery pack holder actually in the design. You can't see it, but it's kind of sitting there right now. And then finally, we really probably do a lot more calculations on the propeller wheels to make sure we're getting back slow through the design. In terms of the future market potential, the design, I really think there's two major different ways this could go. You can either get rid of the motor, make it a cheap back toy for kids, maybe ages 3 and up, where they can pull it back and let it go in the water, have it sink, play with it in that sense, would be maybe a $15 toy. Without any motor, you wouldn't have to worry that much about sealing it because, again, it's stuff like electronics. The other option you could go with it is to turn it into a fairly expensive hobby toy, where it's really highly engineered. It's remote controlled acceleration and steering. Potentially the piston actually remote controlled as well. So kind of how I think it is to be an off-road vehicle that you drive it off into a pond and then you go exploring. Adding cameras to the periscope, go exploring on the bottom of the pond, see what's out there. And just like we kind of done with drones, where we can now go take photos in the sky, take it underwater. Would be kind of the idea with a hobby toy. And then the final thing is interchangeable top shells. So this is probably more for the back toy, but these could just pop on and pop off, and be the J-Fly spy car one day, and then Boilermaker underwater special the next day. So we just think there's really a lot of different ways this toy could go. We're having kind of see it work anyway. Any questions?
Once you guys get the water in, how are you purging it?
Like for the piston?
Oh, so piston purges the whole thing out? I thought it was like...
So the entire thing doesn't fill with water. We just actually have a chamber in there that will fill up. It's basically just a mini piston.
Cool.
We have a few holes on the bottom, which would, in a final iteration, probably be like a grate. Unfortunately, the piston, as we said with the layers of the 3D printing, the O-rings weren't able to get a right tight enough seal around that. So we had to seal those holes for now, but ideally the water's flowing in and out of those with an air release going up through the piston.
Any aquatic environment, maybe make it so that it can fly or...
Yeah, we actually thought about if we just could do everything.
Yes.
But given the few months that we had, we were also very much water out of the edge.
Something that we